of type Boolean. Okay, this is logical OR. The input these logical operator takes is of type Boolean. Now coming to the logical AND, we have input 1, input 2. So as I said, they are of type Boolean. Inputs are of type Boolean. So input 1, input 2 and output. Then here for logical OR also. Anyways, I'll provide it here. Okay. So if the input 1 is false and input 2 is also false, then output is also false. If the input 1 is false, input 1 is true, even then the output is false. If the input 1 is true and input 2 is false, then the output is also false. If the input 1 is true, input 2 is also true, then the output is true. Okay, so that is in case of logical AND. So here in case of logical AND, okay, this is in case of logical AND. Similarly, in case of logical OR, okay, it is represented by two pipes. So here, either of the condition is true, the output will be true. Okay, so this is true, this is also true. Okay, like this. Now, where to make use of this is, whenever you want to check if the two inputs are true. Okay, for example, let's say, check the largest of three numbers. Okay, so I have to check the largest of three numbers. So let's say I'll write it here. Write a program to check largest of three numbers. Okay, so assume you have three numbers from taken from the user, int num1, num2 and num3. Okay, now how will I decide that num1 is the largest of the other two numbers? How will we decide num1 is the largest of the other two numbers? So I am going to decide it with the help of two conditions. Num1 should be greater than num2. Also num1 should be greater than num3. Only then I can say num1 is largest. So inside if condition I have to say num1 is greater than num2. Okay. And your num1 is greater than num3 also. Only then your first one will be the largest. Okay. I have to check for both the conditions. First one should be true. Second one should also be true. So true and with true will be a true. So you will get the result whatever you have written inside this if condition. Okay. So here in case of if condition, I am going to add one printf saying num1 is largest. Okay. So I am going to say num1 is largest like this. Now, if not num1 is largest, then maybe I have to decide between num2 and num3. Okay. If num1 is not largest, else I now have to decide between num2 and num3. Okay. Now to decide num2 is largest, I am going to check. Num2 should be greater than your num1. Okay. To decide num2 is the largest, I have to check num2 is greater than num1. Okay. Also, I have to make sure num2 is greater than num3. Then I can say num2 is largest. Okay, so here I am going to say num2 is largest. Now if neither of them are largest, then obviously I have to go to the else block to say num3 is largest. Okay, so here I am adding one printf saying num3 is largest. So like this, we are going to make use of logical AND to check the largest of three numbers. Whenever I want to check for more than one condition and I want to make sure both the conditions are being satisfied, I have to make use of the AND operator. Okay, logical AND. Now tell me one more question. How to check if a number lies between 50 to 100? Okay, check if the number lies between 50 to 100. How to check that? I want to check if the number lies between 50 to 100. Okay, so assume I have a number. What should be the condition? So in order to check if the number lies between 50 to 100, I cannot alone say okay. So I cannot just decide based on number is greater than 50. Just if number is greater than 50 doesn't mean it is lying in the range. Okay. Yes, I have to check if your number is greater than 50. In fact, if you want to include 50 also, you can write greater than or equal to. And you also have to check number is less than or equal to 100. So only then you can add a printf saying number lies between 50 to 100. Lies between 50 to 100. So in the else block, I am going to say not in range. Okay. So like this, you are going to make use of the logical operators. So logical AND is used to check for more than one condition. Okay. And logical OR is used to check if either of the condition is true you want to execute, then you can make use of logical OR. Okay. Now, so that is about logical AND. So in case of logical OR, either of the one input is true, you will get the statement executed. Then we have something called as logical NOT also. Okay, we have something called as logical NOT. Logical NOT is represented by a exclamatory mark. Okay, now what happens in logical NOT is I have one input and one output. Okay, so I have one input, I have one output. So what happens in logical operator is if the input is true, output is false, input is false, output is true. Okay, so this is false, this is true, and this is true, this is false. Okay, so that is logical NOT. So here in case of logical NOT, whenever you are using, for example, let's say I have an integer variable called num whose initial value is 10. Okay, so I'm going to write result is equal to NOT of num. So num is nothing but 10. 10 is a non-zero value which is treated as true. So I should find what is NOT of true. NOT of true is false. So num gets assigned with false. The decimal equivalent of that is 0. So result gets assigned with 0. Okay. We have logical NOT also. So logical NOT is used to NOT the logical values. So NOT of true is false and NOT of false is true. So these are the basic logical operators. And we are using basic gates for logical operation. Yes, it is your basic AND OR operators only being used. Okay. So then Arav is asking, let me just copy that. So he's asking, is it possible to write it like this? Is it possible to write if num is greater than or equal to 50 and if num is less than or equal to 100? No. So you cannot use two ifs like this. You have to make use of a single if condition like this. Okay. If number is greater than or equal to 50 and the number is less than or equal to 10. So that is why we write true and true. Between you don't use any other keywords. So that is your logical operators. Can you look at this and tell me what will be the output? Okay, Krishna is asking, in my offer letter, my college name was incorrect. When we have to change it? You can mail to the support team. They will get it corrected. Okay. Now coming to this, Martha Haritha is asking, kindly explain more clearly about increment and decrement. You can see here one good example for increment and decrement. Okay. So the initial value of num is 1 and num2 is 0. Okay. So num1 is having the value 1, num2 is having the value 0. So plus of num1, we are going to increase the value. Or is when the first input is true, it will not check for the second input. Okay. So I have true and I am using logical OR. My first input is true. So whenever my first input is true, I'm not going to waste the time in checking for the second input. Okay. So that is because of logical OR. You see here, when the first input is true, output is true. First input is true, output is true. Whether the second input is true or false doesn't matter. The moment first input is true, output is true. Okay. So because of that reason, in case of logical OR, when the first input is true, it will not check the second input. It directly concludes the output as true. So num1 becomes 2 and num2 is unchanged. It remains 0. Okay. So num1 is 2 and num2 is unchanged. It remains 0. So this statement will not get executed at all. So because of the logical OR. Then coming to the second statement, num1 is 1, num2 is 0. So 1 plus plus, the value considered here is 1. But for the next time, it will be updated to 2. Whenever you access num1 for the next time, it should be updated to 2. This is post increment. Incrementation happens for the next time you access. So here I have a 1. Okay. 1 and with 1 is nothing but true. True and with plus plus of num2. So num2 changes to 1 immediately. So that is also true. True and with true, we will get the output as true. So we will enter the if condition. I am accessing num1 which has become 2 here and num2 is 1. So 2 and 1 will be printed. Okay. In this statement 2 and 0 will be printed. In this statement 2 and 1 will be printed. Okay, so that is about your logical operators. Then we have relational operators which you have already studied. Later we have assignment operators. So assignment operators are used to assign the value to a variable. Okay, all of your assignment operators are used to assign the value to a variable. So here I am trying to assign the value to the variable on the left hand side. Okay. So now what happens is in this case, I am using an assignment operator. I'll just copy this and explain how this is going to work. Okay. So plus equal to is one assignment operator. So when I say num3 plus equal to num4, it will be seen by your compiler as num3 is equal to num3 plus num4. Okay, it's an assignment operator. Whenever we say num3 plus equal to num4, it will be seen as num3 equal to num3 plus num4. So the initial value of num3 is 1.7. Okay, the initial value of num3 is 1.7. Then num4 is 1.5. So num3 plus num4 happens to be 1.3 plus 1.5, which will be 3.2. So num3 gets changed to 3.2. Okay, your num3 is changed to 3.2. And in this place, it gets replaced with 3.2. Okay, it gets replaced with 3.2. Next, I have num2 plus equal to 3.2. Okay, like this. Num2 plus equal to 3.2. So it is num2 equal to num2 plus 3.2. So num2 is 1. 1 plus 3.2 is 4.2. Okay, so this will be 4.2. But I am storing inside num2. And num2 is one integer variable. Okay, num2 is a local integer variable. So when I write num2 equal to 1, because it is integer, it cannot store 4.2. Num2 only takes 4 here. Because it is integer, it only takes 4. Okay, so this statement gets replaced with 4. Then num1 plus equal to 4. Okay, so num1 plus equal to 4 means it is num1 is equal to num1 plus 4. So num1 is 1 right now. 1 plus 4 is 5. So your num1 gets assigned with 5. Okay, so your num1 is assigned with 5. And we are printing the value of num1. So we get 5 printed here as the output. Okay, So we will see 5 here as the output. Okay. Ma'am, it is 4.2 plus 1. No. As I said, here, in case of num2, num2 plus 3.2 is 4.2. But num2 takes only 4 stored. So it is not storing 4.2 because of type integer. Only 4 is stored. Then I'm going to add it. So I'm going to get 5 printed. Okay. So I'll just copy the statement and put it here. Okay. I am repeating again. Okay. So here first I have to solve. See, I have multiple plus equal to here. Okay. So I am solving from right to left because the associativity says right to left. So I am solving from right to left as the associativity says right to left. So first I have to solve num3 plus equal to 4. So when I solve num3 plus equal to 4, it is num3 is equal to num3 plus num4. So num3 gets the value 3.2. That 3.2 gets replaced at this place. Okay. So here at this place 3.2 gets replaced. So I'll just highlight here. At this place 3.2 will be replaced. Okay. So here 3.2. Next, I'm going to solve this. Num2 plus equal to 3.2. So then I write num2 is equal to num2 plus 3.2, which is 4.2. Okay. But num2 is integer, so num2 stores only 4. It cannot store 4.2. It stores only 4. So this statement gets replaced with a 4. Okay. So this statement is going to get replaced with a 4. Then num1 plus equal to 4. Num1 plus equal to 4 becomes 5. So 5 will be the output. So here num1 gets assigned with 5. So we print the value of num1, 5 will be printed. Okay. So post increment will increase the value of a variable for the next time you access. Pre-increment will increase the value of the variable immediately. Okay. So most of you are asking how to get the recorded sessions. Guys, you have to log into this platform called LMS. So there is a platform called LMS here, whose link I have shared it here. So this is the link to log into LMS. So when you log into LMS, you will see one dashboard screen. So in that dashboard screen, we have a section called C module recordings. So here you will see all the recordings. As of now, I have not added any. Okay. So here I am going to add one. So let's say I will add your class 1. Okay. So whatever is the class 1 recording, I will add here, which was taken on 13/5/2025. Okay. So I have spoken about the introduction to C basic. So all of that I will add here. I will update the link. When you click on that link, you will be able to access it. Okay. It will be ready by today. You can Start watching the recordings from today. PPT, your question about PPT, it is there. I told you in your LMS, you get a section called C Programming Resources. See here, all advanced C slides are there. So your resources are there, your assignments are given, your templates are given. So you can explore them. How to log in? So click on this link, type this link in your URL and you will get the login screen. You have to enter your email ID and password. So password will be shared to you via your mail. What is not of num? Kindly explain. Okay. So num here I took as one integer variable. Okay. The num here is one integer variable. So when I say not of num, num is one integer variable representing the value 10. Because it is a non-zero value, it is treated as true. So not of true is false, result gets assigned with false. The decimal equivalent of false is 0, so 0 will be provided. Okay. Then one more example of assignment operator here. Num1 is assigned with the value 1. In place of condition 1 will be taken. If of 1 is always condition true, so it prints yes, it is equal. Okay. Remember the assignment operator. On the left hand side we will have a variable. On the right hand side we will have a value to be assigned to a variable on the left hand side. Okay. So that is about your assignment operator. So let us take a break of 2 minutes. We'll start with bitwise operator. Okay. So let us continue. Okay, Omkar is asking, ma'am, for becoming a successful embedded engineer, do we have to study data structures in C or C++? Okay, so basically not necessary. Okay, so this is one of a question. I would say not necessary. Depends on how you are working. So not necessarily you don't need data structures as such, as long as you're dealing with a big amount of data. Okay. So ma'am, I'm not able to understand not of num is integer and it's false. And also the decimal equivalent is 0. Kindly explain one more time. Okay. See here. I'm taking int num with the value 1. Okay. So I'm writing result is equal to not of num. Okay. So here result is one integer variable. So inside result, I should store one integer value only. Okay. Now, when I say not of num, so this is not of 1. Okay. Not of 1. So 1, in case not is an operator which takes input in terms of true or false. Okay. Any non-zero value is true, 0 is false. Non-zero value, it is treated as true, and a 0 is treated as false. Okay, 0 is false. So because of this reason, here it is a non-zero value. Boolean we have to consider. So it is a non-zero value. Because it's a non-zero value, I am going to treat it as true. So not of true. Okay, not of true. So non-zero value, it is not of true. Not of true is false. Okay, not of true gives me false. Now, I should store this false into a variable called res. So I should write it like this. Res is equal to false. But res is one integer value. You can store only one integer. So false is represented by integer 0. Hence, res receives the value 0. Okay. Now moving on, we have is bitwise operators. So bitwise operators are used to perform the operations on bits of a number. Okay. So in case of bitwise operators, you are going to perform the operations on bits of a number. Okay. So all the operations are performed on bits of a number. So bits in the sense binary digits. Okay. Bits in short is representing binary digits. Binary digits means 0 or 1. Okay. So bitwise operations are going to perform the operations on bits of a number. The input to the bitwise operator should be integer. The return type of the bitwise operator should also be integer. Okay. All the bitwise operators are going to perform the operations on bits of a number. You take one integer, you perform the operation, and then you are going to provide the operation done. Okay. Now coming to the bitwise operators, I will teach you how to use the 6 bitwise operators in C. So we totally have 6 bitwise operators. Okay. So the bitwise operators we have is bitwise AND, Okay, bitwise AND, then we have bitwise OR, then we have bitwise XOR, we have bitwise complement, then we have bitwise left shift, and we also have a bitwise right shift. Okay, so we totally have 6 bitwise operators: bitwise AND, bitwise OR, bitwise XOR, bitwise complement, bitwise left shift, and bitwise right shift. Okay, so Sushant is asking, got that ma'am, what is decimal equivalent of 0, what it means? See, RES should be assigned with false. False is boolean. I cannot store some boolean value inside result. Result should store only some integer. Integer means decimal value. I don't know if you people remember decimal, octal, hexadecimal and all. So decimal, if you do not remember, go do a small self-study. So decimal equivalent means integer equivalent. For false, integer equivalent is 0. So your computer assigns result with 0. And I wrote hundreds of codes and never used int or void before main function nor return statement. It is okay. By default, if you don't write, if you just write main like this, Manikanta, if you just write main like this, by default, it treats it as integer. Okay, so it is okay. You can just write main like this. It makes no difference. Okay, now coming to the bitwise AND. Okay, I'm going for one simple example. So this is bitwise AND. Bitwise AND is represented by one ampersand like this. Okay, so bitwise AND takes 2 bits as its input, just like your logical gates. So this is your input 1, then I write input 2, and output. When we are going to start the project, after C module. So if the first input is 0, second input is 0, output is 0. Then 0, 1, 0. 1, 0, 0. And 0, 0, sorry. 1, 1 is 1. Okay. So I will show you an example. So there is one integer variable called num assigned with 10 and num2. So num1 assigned with 10. Sorry, num1 assigned with 10 and num2 assigned with 30. Okay. Now what happens if I do result is equal to num1 logical AND with num2. This is logical operator. So logical operator input is true or false, output is true or false. Okay, logical operator input is true or false, so output is true or false. So now what happens is, this is logical operator. Num1 is representing 10, hence it is treated as true. Then num2 is representing 30, It's a non-zero value. Again, it is true. So true and with true will be true. Okay. True and with true will be true. So result should be assigned with true. My result cannot store a true. It should store one integer value because my result is one integer. Result should store only one integer value. So in place of true, a 1 gets stored inside result. So when you use logical operators, you are speaking in terms of true or false, both for the input, also for the output. But in case of bitwise, so if I write result is equal to num1 and with num2. Okay, this is bitwise and. This is logical and. Okay, this is logical and this is bitwise and. Okay, now what happens in case of bitwise and? You should represent num1 in binary. You should represent num2 in binary. Then you have to perform the operation. Can you tell me how to represent num1 in binary? How to represent 10 in binary? Learn how to convert a number from decimal to binary. This is in the decimal form. Learn how to convert decimal to binary, octal to binary, hexadecimal to binary. You have to study that. Okay. 10 represented in binary is 1010. Okay. But I will add few zeros here. So I am representing 8 bits. 00001010 is 10 in binary. Then 30 in binary is, it is 0001. So it is 16 plus 8 is 24 plus 6 is 30. Okay. This is 30 represented in binary. Okay. This is 10 represented in binary. This is 30 represented in binary. Now I have to perform bitwise AND. So 0 and with 0 will be 0. 0 and with 0 is 0. Again 0, again 0. This is 1, this is 0, this is 1, this is 0. Okay. So this ends up giving us 10 as the output. Your result gets the value 10. Okay. So your result gets the value 10. So that is how you perform the bitwise AND. So you take the number, represent it in binary. Both the inputs should be represented in binary. Then you have to perform the AND operation. Now I'll show you what is bitwise OR. Okay. So bitwise OR. So in case of bitwise OR, this is 1, this is 1. So if integer num1 has the value, integer num1 has the value 24, okay, and your num2 has the value 32, tell me what is num1 OR with num2. So this is logical OR. This is bitwise OR. Bitwise OR. Okay. Now what is the result? So you should represent num1 in binary, num2 in binary, and what is the result? What will be the result for OR? Okay. So now num1 represented in binary is, okay, so here we have got 0, 0, 24. So it is 16 plus 8. So this is 24 in binary. Then num2 is 32. So 0, 0, 1, 0, 0, 0, 0, 0 is 32. Okay. Now we are going to perform OR. So here 0 OR with 0 is 0. Okay. Like the 0 OR with 0 is 0. Then this is a 0. This is 1, 1, 1, 0, 0, 0. So how much is this? This is 56. Okay. So 32 plus 24. This will be 56. That is bitwise OR. Okay. Similarly, you have bitwise XOR. Bitwise XOR. I'll just copy this. So this is bitwise XOR. Okay. Represented by a cap. So this is represented by a pipe. Okay. This is represented by a cap. So this is the truth table of bitwise XOR. Two inputs are same, output is 0. Two inputs are different, the output is 1. So let's see how many of you will be able to do it. I have int num1 with the value 29 and num2 with the value 47. Int num1 with the value 27, num2 with the value 49. Okay, so you have to say what is result is equal to num1 XOR with num2. Then how to analyze 56 and 32 number. So this you have to learn how to convert decimal to binary, how to convert binary to decimal you should learn. If I start teaching all of that, it takes 10-15 more days. This is basic you would have learnt in your academics. This is not something you are learning later. Will the result be in binary or integer? It will be in integer form. So any bitwise operator, input is integer, output is integer. But while performing the operation, it represents the number in binary and then does it. So I have to represent num1 in binary, num2 in binary, then find the result. What is 27 in binary and 49 in binary? Okay, so 27 in binary is 00011011. Okay, and num2 in binary is 49. So 49 in binary is okay. So 49 in binary is 00110001. So this is 49 in binary. After we perform the operation, inputs are different, output is 1, inputs are same, output is 0. So here 0, 0, 1, 0, then 1, 0, 1, 0. Okay. So the decimal equivalent is so 1, 0, 1, 0, 1, 0. Yes, the answer is 42. Okay, So that is bitwise XOR. Next, you will also have bitwise complement. Bitwise complement. So bitwise complement means inverting the bits. Okay. So bitwise complement is inverting the bits. So it takes only one input and gives one output. Like this. So if the input is 1, output is 0, input is 0, output is 1. Okay. So it's like this. Integer num is equal to 50. What is complement of 50? Complement of 50. Okay, like this. I mean, what is complement of num? You invert all the bits. So num represented in binary is, I'll take it in 8 bits. So 0, 0, 1, okay, 32 plus 16. Minus 50 is not the answer, no. So 0, 0, 1, 1, 0, 0, 1, 0. So this is 15 binary. Complement of that is you invert all the bits. Okay, it is not minus, it is complement. Okay, so here you will have 1, 1, 0, 0, 1, 1, 0, 1. Okay, so 1, 1, 0, 0, 1, 1, 0, 1. So you get how much? 205. Okay, so complement of number is 205. So that is complement. Then we have is left shift. Okay, so next we have is left shift. So left shift means shifting the bits of a number to the left. Okay, that is left shift. So let's say there is an integer variable called num stored with 10, or I'll take 15. So I want to do number left shifted for 2 times. Okay, in RES is equal to number left shifted for 2 times. So I first represent number in binary with the help of 8 bits. So like this, I have my number represented in 8 bits like this. Okay, so after representing the number in 8 bits, I have to shift to the left for 2 times. Okay, so whenever I perform the left shift, this first bit we call it as most significant bit, MSB bit. So that bit is called as most significant bit. This bit is called as least significant bit because it has the least prominence. Okay, we call it as least significant bit. So after representing 15 in binary, I'll have 0, 0, 0, 0, and I'll have 1, 1, 1, 1. Okay. Now I have to left shift for 2 times. So I have to shift all the bits to the left for 2 times. Okay. First I will do it for 1 time. So whenever I am performing the left shift, MSB bit is lost. Okay. So remember your MSB bit is lost. Okay. This bit will be lost. Then your LSB is filled with 0. LSB will be empty. So LSB will be filled with 0. LSB will be filled with 0. So after shifting it to the left for once, I will have 0, 0, 0, 1 and 1, 1, 1. LSB will have a 0. Then I have to shift it for another time because the question is to shift to the left for 2 times. So I am shifting it for another time. So after shifting it for another time, again LSB bit is lost. Sorry, MSB bit is lost. Here I will have 0, 0, 1, 1, okay, and 1, 1, 0, 0. So LSB bit will be empty, so you always have to fill it with 0. Nothing else. You cannot add 1 because adding 1 will change the value. You have to add 0 itself. So after shifting it for 2 times, okay, here you will have 0, 0, 1, 1, 1, 1, 0, 0. So this is 32 plus 16 is 48. 48 plus 12. Okay, so the answer is 60. So the output you get is 60. So that is what you do for a left shift. Okay. Now that is left shift. Similarly, we have a right shift also. So let us see how right shift works. So in case of right shift, okay, you have to shift the bits to the right. Okay, I'll show it here only. So this is right shift. Okay, whenever you are shifting the bits to the right, you are going to add zeros there. Okay, LSB bit is lost, MSB bit will be filled with 0. So that is right shift. So whenever you are performing the right shift, remember this. Okay. Now right shift has two things. Okay. We have a signed right shift and an unsigned right shift. Signed right shift. Okay. And we have an unsigned right shift. This you don't worry much. Just remember it like this. Unsigned right shift. Or I think I'll directly say only right shift. Okay. So in case of right shift, let's say I have an integer variable called num assigned with 20. So I want to write result is equal to number right shifted for 2 times. Okay. I want to perform the right shift. So I'll just copy it like this. Okay. This time we are performing a right shift. So I'll remove this. So whenever a right shift is performed, this time this is our MSB. This is our MSB. and this is the LSB. Okay, so I should represent 20 in binary. So this is 20 in binary. Okay, so I have to perform the right shift. All of my bits should be shifted to the right for once. Okay, so all of the bits should be shifted to the right for certain number of times. So when I'm performing the right shift, the MSB bit is shifted to the right, LSB bit is lost, MSB bit is empty. So you are going to fill MSB with 0. Okay, this is your LSB, so it will be lost. Okay, and your MSB bit will have a 0. So I will say LSB is lost and MSB is filled with 0. Okay, so here I'll have 0, 0, 0, 0, 1, 1, 0, 0. So I should perform the right shift for another time. Okay, I'll take 24 only, sorry. Okay, I'll change it to 24 only. So this is 0, 0, 0, 0, 0, 1, 1, 0. So this LSB bit is lost. Okay. Yes, my mistake. Instead of 20, I wrote 24. So I changed the number to 24 only. So this is the number. Now if you look at the binary decimal equivalent of this happens to be 6. So the output here is 6. Okay. So that is right shift. Shifting the bits to the right, we call it as right shift. Okay. Then we have size of operator. Size of is an operator which tells you the size of the variable. So size of integer, size of num, size of 5, size of is something which tells you how many bytes of memories are allocated. Okay. Next, we have something called as ternary operator. So ternary operator is a substitute to the if else. Okay, ternary operator, it is a substitute to if else. Okay, simple if else can be written using ternary operator. For example, I want to check the largest of two numbers. Okay, I want to check the largest of two numbers. To check the largest of two numbers, we will make use of one if condition. Assume I have two integer variables num1 and num2. So I want to check if num1 is greater than num2, I am going to say num1 is largest. So printf num1 is largest. Okay. So else I am going to say num2 is largest. So here I am going to say num2 is largest. Okay. So that is your largest of two numbers. Now to replace it with a ternary, you can write it like this. You can write a condition. If the condition is true, what you want to do, write it here. Colon. If the condition is false, what you want to do, write it here. Okay, false like this. Now for example, condition is num1 greater than num2 question mark. That is the condition. If it is true, I want to say num1 is largest. So I'm going to write it here. Otherwise, colon, if it is false, I want to write num2 is largest. Okay, terminated by a semicolon. So that is how you write a ternary operator. It's a substitute, it's an alternate to the simple if-else block. So you want a very simple if-else block to be returned, you can write a ternary operator like this. Do you understand? Okay. So one last topic for today, we have overflow and underflow. Do you remember the size of range of short integer? Short integer. What is the minimum value you can store? What is the maximum value you can store? In short integer, what is the minimum value and what is the maximum value for short integer? So I'll take it from here. Okay. So Shant is asking, will it work for else if 2? No. Else if 2, you are going to make use of ternary only. It is nested ternary. It is quite complicated, not necessary to be known now. Okay. This is the minimum of a short integer, maximum of a short integer. Okay. Now what happens if I store a value which is out of this range? Okay. This is the minimum value, maximum value. I take short integer num with the value 43789. Okay. 43789. What happens? If short integer is stored with 43789, what happens? So, I am trying to store a value out of the range. Okay. The value I am trying to store here is out of the range. It will not give me any error. Okay. Just because I am storing the value out of the range, it will not directly throw me any error. Instead, it might not store the value what I am trying to store. Storing value any out of the value greater than maximum. Yes, it stores some garbage value. Okay, it stores garbage value. So it is out of the range. Storing a value greater than maximum value is called as overflow. Okay, storing a value greater than maximum value is called as overflow. Okay, is called as overflow. Similarly, storing a value lesser than the minimum value, we call it as underflow. Okay, storing a value lesser than the minimum value is called as underflow. So, whenever it is overflow or underflow, you will never come across any error. Okay, when it is overflow or underflow, you will never come across any error. But remember, in this case, you will end up having some random values stored. Okay, be conscious. In case of short, the minimum you can store is this, maximum you can store is this. Storing anything beyond this leads to your overflow or underflow. It happens for integer, It happens for character. It happens for long integer. It happens for long integer also. So that we call it as overflow and underflow. Be conscious to have the proper value stored. Okay. So that is it about the operators. The next we have got to start with is arrays. Okay. So in tomorrow's class, we will study about arrays. So in tomorrow's class. Okay. So we are going to study about arrays and pointers. Okay. So that is the focus for tomorrow's class. We will study about arrays and pointers. So that is it for today. Hope you people have understood the operators we have discussed, about the ternary operator and also about the overflow and underflow. So we will continue arrays and pointers in the next class. Thanks for attending today's session. We'll continue tomorrow. Thank you all.